Acha, so once we're done with permutations and combination, inshallah, we will start off with vectors. Okay, but that's going to be next Sunday. Vectors is another topic that doesn't really have a prerequisite. Okay, so we can do that. It's an independent topic basically, and I think that's going to take us another two classes at max. Have you guys done vectors in maths in school?
Yes.
Okay.
Even in admin, it's supposed to come in your mocks, but like it
Mm-hmm.
was very rushed. Yes.
Okay. Fair. I'm not going to be entirely relying on the fact that you guys have done it. We will be doing it from scratch. So if you haven't done it in maths, it's okay. Like I said, I'll be doing it from scratch anyway, inshallah. And vectors of hard maths is quite different compared to vectors in math. Hard maths is more
Yes, sir, especially the
concentrated.
proving.
Yeah, hard maths
Especially
is
the proving part.
exactly. So if you look at all the questions of vectors, you can divide it in I think three categories. Okay, one is where you have to find lambda and mu. The other is the velocity vectors part, which a lot of people think is not in the syllabus, but it is in the syllabus. Okay, resolving vectors and resolving velocity, that part is still in the syllabus. The only thing that's not in the syllabus is relative velocity. Okay, yeah, that was removed in 2019. Yeah, I think 2019 was the last year that relative velocity was tested. 2020 onwards, it was removed. And the third is what's the third category? I think it's only these two categories where you have to find lambda and mu, and the other is resolving vectors, resolving velocity using vectors. Okay. Okay, so let's get to work. Like I said, we will be doing, since we're done with all the concepts of permutations and combinations, we will be doing past paper questions of permutation combination. Okay. Once we're through with this class, I will share this file with you guys. Okay, so you guys can practice it if you want. And yeah, so let's get to work. So I've chosen a few questions that we're going to solve. Okay. So in a way so that we're able to cover all the concepts. Okay. So we'll start with numbers like these where you have to form numbers using the digits provided. Okay. We've done quite a few examples like these, so it shouldn't be a problem. So I will solve 2-3 questions for you guys, and then I will give you guys a few questions to solve. Okay. And with the passage of time, you'll realize that yes, there are like 3 to 4 type of questions of permutations and combination that you will be tested on. Okay. Okay. So this is a question from, oops, hang on. So this is a question from October-November 2014, paper 1, variant 2. Okay. So it says here, find how many different 4-digit numbers can be formed using the digits 1, 2, 3, 4, 5, and 6 if no digit is repeated. Okay, so that's a pretty simple question. You're forming a 4-digit number, so you make 4 blanks, 1, 2, 3, 4. Now, how many digits do you have? You have 1, 2, 3, 4, 5, and 6. So you can do this with permutation, or you can do this without permutation as well. It's entirely up to you how you want to do it. So if let's say we do it without permutation, so that means for the first digit, how many options do we have? Since there are no restrictions, okay, you don't have to form an even number, odd number, or a number that's greater than a certain number or lesser than a certain number. Okay, so it's without any restriction. So for the first digit, you have 6 options. Okay, and then for the next digit, since you can't repeat a digit, how many options do you have? For the next digit, you have 5 options. Yeah, sorry, and then you have 4 and 3. And if we were to do this with the help of permutation, this would have been simply 6 before. Okay, so irrespective of how you do it, the answer will turn out to be as 360. Okay, so fairly easy question, nothing too complicated going on over here. And there you go, that's the answer. Now let's do part 2, see what it says. So in part 2 says how many of these 4-digit numbers found in part 1 are greater than 6000. So now we have a restriction. If you want the number to be greater than 6000, you can only have what as your first digit, considering that we have 1, 2, 3, 4, 5, and 6. How many options do you have? Yeah, you can only have 6 as your first digit. So that means there's only one option. Okay. Now we started off with how many numbers? We started off with 6. Now from the 6, 1 is gone, and that number which is gone is 6. So how many are we left with now? We're left with 5. So that means that's the number of options that we have for the second digit. and then 4, the number of options for the third, and then 3, the number of options for the fourth digit. So you multiply all of these together. So what do you get? 5 into 4 is 20, 20 into 3 is 60, 60 times 1 is 60. Okay, or you could have done it like this: 1 P1, okay, for the first digit, into 5 P3 for the remaining 3 digits. So 5 P3 is still 60, 1 P1 is 1. Okay, so sir, what is the expansion of NPR? Okay, so the expansion for NPR, okay, that's a good question. So let's say you have 6P4. You can actually tell what the expansion of 6P4 is by just comparing the two. Okay, so 6P4 is actually means that you start from 6 and then you go one place backwards, so that's 5, and you keep on doing it till you have 4 digits. Okay, so 6 into 5 into 4 into 3. So that's the expansion of 6P4. Okay, and then you can use this to expand whatever it is that you want. Okay, I hope that answers your question. Okay, then comes part 3. Part 3 says how many of the 4-digit numbers found in part 1 are greater than 6,000 and are odd. So let's see, we might have a conflict situation. Okay, we might, not necessarily. Let's say, judging by the marks, do you think this is going to be a conflict situation? No. Okay.
No, it can't be. It's only 1 mark.
Yeah, it's only one
If
mark,
it's a conflict
exactly.
situation, at least it would be 2 or 3.
Yeah, yeah. So see, these are the patterns that I want you guys to pick gradually. Okay. So odd, if a number has to be odd, that means you can have 1, 3, or 5 as your first digit, or as your last digit, and you can have 6 as your, I mean, you need to have 6 as your first digit if you want it to be greater than 6,000. So that means how many options do you have for the first digit? You have one option. How many options do you have? Yeah, 1P1 and then 3P1. That's correct.
And 2P2.
2P2? Are you sure? 4P2.
2P2. 4P2.
Why? Because we started with 6 digits. Of the 6, 2 of them are gone. Okay, so that means now we're left with how many? Now we're left with 4. Okay, and how many options do we have? I mean, how much space do we have? We have space for 2. Okay, so 1P1 into 4P2 into 3P1. All right, irrespective of how you do it, you get the same answer. So 1P1 into 4P2 into, let me write that again, 4P2 into 3P1. So let's work this out. 1P 36. 36 is the correct answer. Okay, good job. Thank you. All right, now, so this category was like a number category. Okay, and you'll find these very common in past papers, and they will more or less be like this. Okay, the max that can happen is that you can end up with a conflict situation where the number that can be your last digit can also be your first digit, or vice versa, in which case you have to just split them. Okay, but we will do more questions dealing with numbers later on. Okay, now let's do this question. Okay, so this part actually, it says a quiz team of 10 players is to be chosen from a class of 8 boys and 12 girls. All right, find the number of different teams that can be chosen if the team has to have equal number of girls and boys. Okay, so if you're making a team of 10 players, and you need to make sure that the number of girls and the number of boys are equal. So we don't really have a lot of options. Why? That means how many? Yeah, but how many boys can we have and how many girls can we have if we have to make sure that 5 each? That's correct. Equal number of girls and boys. Okay, so like I said, we don't have a lot of options. So the number of boys can be 5 and the number of girls has to be 5 as well. So how many boys are you choosing from? You're choosing from 8 boys. Okay, so that means you have 8C5 options as far as the number of boys are concerned. And how many girls are you choosing from? You're choosing from 12, so 12C5. All right, so we multiply them. 8C5 into 12C5. Okay, so your answer is 44,352. Okay, now this is kind of weird because it's a 3-mark question, but I'll tell you exactly. Yeah. 8C0. But it says that it has to have equal. It says it has to have equal. Okay, and we need to have 10. Okay, one of the we could have taken 4, 4, 3, 3, 2, 2, 1, 1, but we need to have 10. Total has to be 10. So 10, if you divide by 2, it's 5. So that means you gotta have 5 each. You don't have any other option. Okay. Acha. Now, next question. The next question is, next part actually, the next part is that find the number of different teams that can be chosen if the team has to include the youngest and the oldest boy and the youngest and the oldest girl. Okay, so what do we do now? I'll solve this, okay? Since this is like the very first question, so I'll solve this. So they call. Let's first highlight what's important. Find the number of different teams that can be chosen if the team has to include the youngest and the oldest boy. Okay, so if you
already have two things.
Yeah.
4 things are already there set for you.
Yeah, so basically, if we talk about the youngest and the oldest boy, that means youngest will be 1, oldest will also be 1, and you have to include them. Okay, so that means there are 2 of the 2, one is youngest and the other is the oldest, and you have to include both of these 2. So how do you do that? You do that by 2C2. You have 2 people to choose from and you have to choose both of them. So that's 2C2. Just like that, it further says, and the youngest and the oldest girl. Okay, youngest means 1, oldest means also 1. So together that's 2. So that means now you have 2 people to choose from and you have to choose both of them. So that's going to be another 2C2. Okay, now this is the tricky part from this point. We were selecting a team of 10 players. Okay, but how many have we selected now? We've already selected 4. Yes, great. We've already selected 4 of them. Okay, now previously we were selecting from a total of 8 plus 12, which is equal to 20. Okay, but considering that we have already selected 4, that means now we are selecting from the remaining 16. Okay, so I'll walk you guys through this again. So the youngest and the oldest boy means there are 2 people and they have to be in the team. Okay, so the only way the 2 people can be in the team is 2C2. Okay, and just like that, the youngest and the oldest girl, 2 people, both of them need to be in the team, so that's another 2C2. Okay, now previously we were selecting from 20. Okay, now from the 20, the youngest girl is gone, the oldest girl is gone, just like that, the youngest boy is gone, the oldest boy is gone. Okay, so that means now we're selecting from the remaining 16 because these 4 are not, you can say, part of the squad anymore from which you're selecting. They're not part of that pool anymore. Okay, so that means they're on the side. Now we're selecting from the remaining 16. Okay, and how many are we selecting? Considering that we were supposed to select 10, of the 10, we've already selected 4. So that means now we're selecting 6. So that's correct. So 16P6. Now you work this out. 2C2 is going to be 1. And 2C2 again is going to be 1. 16C6. If you work this out, let's see. 16C6. Yep, 8008. That is correct. Good job. Acha. Now you may be thinking, just a minute. So there's a question which Mohammed Hassan has asked, is that can we do 4C4? Yes, you could have done 4C4 as well. Okay, because altogether this makes up 4 players and you have to include all 4 of them. So you could have done 4C4 into 16C6 as well. Okay, so it makes no difference. But my suggestion is to all, if there's a separate category, then do it separately because this method will extend it in later questions as well. Oh, yeah, thank you for pointing that out. I don't know why I've written 16P6. Halaki calculator, I did 16C6. Okay, yeah, thank you. Okay, now let's have your questions. Omar, that was a mistake. It was not 16P6, it was actually 16C6. And what? Acha, chalo, that brings me to another question. Why are we using C over here? Why not P? Yeah, because we're selecting. Because, yeah, when we're making a team, the order doesn't matter. That's correct. Acha, but why do we do 16C6? Okay, so is your question is why do we do C, or is your question focused on this 16 and this 6?
16 and 6.
Okay, so remember how many people do we have to choose from? We have 8 plus 12, which is equal to 20. Okay, so how many people are these? Youngest boy, oldest boy, youngest girl, oldest girl. How many people are these?
Yes.
4.
These are like 4, yeah.
4, okay. So if we have to select a team of 10, and considering that we've already selected 4, so how many are we selecting?
16 now, right? 16 already.
16 is what we're selecting from. Okay, that was going to be my that was going to be my other question. So previously we were selecting from 20, and considering that we've already selected 4, that means now we're selecting from 16, and since we have to make a team of 10 and we've already selected 4, so that means now we need to select another 6. So that's why we have 16P6.
Thank you.
Achha, what is the expansion of NCR? I've already explained that in binomial. Okay, how to expand NCR. when we come across a question, I'll give you a recap. Okay, there is a question in permutation combination where you have to expand NCR. Okay, so don't worry about that. Acha, let's do another question. Yeah, here it is. Because, yeah, this is a question that I want to do with you guys. Okay, so in combination, you will always come across questions like there's a husband and wife that can't be separated, there are twins that can't be separated. Okay, and can't be separated is different from must be in the team. Okay, you'll realize that once we do a few questions. Okay, so this is a question from May June 2014, paper 11. Paper doesn't matter because, as you know, the thing with admaths is, a lot of you have asked me this before as well, that you have two papers only to divide the syllabus. Okay, there's no set pattern of the two papers. Okay, so let's solve this question. Let's see what it says. So it says how many even numbers less than, okay, so this is an interesting question. How many even numbers less than 500 can be formed using the digits 1, 2, 3, 4, and 5? Each digit may be used only once in any number. Okay. Now read this question carefully.
You
And
can only have three spaces out of the 5 digits that you have.
okay, okay. But there's something else in this question that hasn't been specified. No, there's not.
There's a restriction saying that. Okay. No, it's all below 500. So at the first area, you can have 5, 4, 3, 2, and 1. Because it's supposed to be less than 500. No, sorry, you can't have 5. But you can only have 4, 3, 2, 1.
Okay, I agree. I agree with that. Okay, but there's also something else in this question. Acha, let's just quickly compare it with this. Just a minute. Find how many different 4-digit numbers can be formed using the digits so and so. Okay, and then read this question. Exactly. This question hasn't told us how many digits we can use. Okay, so what does that tell you? If it's less than 500, then what are the options? Okay, 3 digits. But are only 3-digit numbers less than 500? Okay, I can see someone.
No, 1 digit, 2 digit, and
Exactly. Yes, yes, yes. Okay. So we can have a 1-digit number as long as it's less than 500, nothing to worry about. We can have a 2-digit number, okay, or we can have a 3-digit number. Okay, as far as it being less than 500 is concerned, that we only have to watch out in a 3-digit number. Okay, it's for damn sure that a 1-digit number will be less than 500, a 2-digit number will also be less than 500. Okay, it's a no-brainer. Okay, now as far as a 1-digit number is concerned, how many 1-digit numbers do you think you can form, given that it's even, using these digits? Okay, you don't really have to use permutation for that. 2 and 4, that's it. Okay, so that means altogether you can form 2. Okay, I hope this is clear. This 2 I'm not writing down the actual digit, I'm writing down the number of numbers that you can form. Okay, and if you want to write down the numbers, the actual numbers, so that's 2 and 4. Okay, so 1-digit number with the numbers that we have provided, you can only form 2 even numbers. Okay, and they are 2 and 4. Okay, for 2-digit, we'll have to do a bit of working. So if you're forming a 2-digit number and you have to make sure that the number is even, so you gotta have 2 or 4 as your last digit. Okay, so that means you have how many options? You have 2 options. Now we have 5 numbers to choose from. Okay, of the 5, 1 is gone. Okay, could be either 2, could be 4, we don't know, and frankly we don't care. Okay, so how many options do you have for the first digit? You have 4 options. 4.
Yeah, 4.
Okay, so 4 into 2 equals to what? Equals to 8. Okay, so remember this is the head count over here. Okay, so
Couldn't it also be possible that 2, because it can't be repeated, right? So wouldn't this be one of the situations where you're going to take 1, 3, 4, 5 and 2 as the last number, and then 1, 2, 3, 5, and then 4 as the last number?
no, so it won't be repeated now. See, the thing is, when we write 2 over here, that means you could have 2 or 4. Okay, but at one point you're only gonna have 1, right? So for example, if 2 is fixed over here, then 4 comes over here, and then just like that, if you have 4 over here, then 2 comes here. Okay, so through this, don't think that the digit will be repeated. So for example, this set won't include 22 or 44. Okay, that would have been possible if, let's say, I would have written 5 over here. That means we started off with 5 digits and now we have 5 again. Okay, that means, and that would be when you're allowed to repeat. Okay, so here you're not allowed to repeat. It says each digit may only be used once. Okay, I hope that answers your question. And there's another question, sir. Why can't we have both 4 and 2 and 2 and 4? Okay, so this already considers that. Okay, so this already considers that if you have 2 over here, then you have 4 here. Okay, and just like that, if you have 4 over here, then you can have 2 in the numbers that you place as your first digit. Why can't we have... okay. Okay, I hope that answers your question also. Okay. If it's not clear, feel free to ask. Okay. You know, you can actually list down the 8 numbers. Okay. I wouldn't recommend that every single time, but if you're having any confusion, in fact, let's do that. So let's do that. So 12 is a possibility. Just like that, 32 is possible. Just like that, 42 is also possible, and 52 is also a 2-digit even number. Okay, what other options do we have? Can we have 24? In fact, let's start 14. With 14. Yeah, 14. We can't have 22, okay, because we can't use a digit more than once. What else? 24 is an option. 34 is an option, and 54 is an option. Can you think of any other possibility? 54. Any other possibility? No. Okay. So when we write 2 comma 4 over here, which means we can have 2 digits as your last digit, that means at one point there's only going to be 1. Okay, it could be 2 or 4, and if 2 is included as your last digit, then it automatically gets deducted from the number of options that you have available. That's why we write 4 over here, because we started off with 5 and now one of them is gone. We don't know which one, that's why we have 4 over here. Okay, so that could also mean that you have 4 as your last digit, okay, which means 2 is still available as your first digit. Okay. All right, now for the third digit, there are 2 conditions that you need to watch out for. Okay, let's see if this is a conflict situation. So you can have 2 here and 4 here as your last digit. Okay, so that means how many options do you have? You have 2 options. Okay, now the number that we have to make is less than 500. Okay, so if the number is less than 500, how many options do we have for the first digit? How many digits can we have? So let's look at that. How many digits can we have if you want to make it less than 500? How many options do we have?
We only have 4. 1, 2, 3, 4.
But
you can't have 5.
Okay, 1, 2, 3, 4. What does that result in?
4.
No, what the TK? But what kind of a situation are we in? This is a conflict situation. Okay, so koi baat nahi. We can always fix this. In fact, I'll let this be, and I'll write it over here that here we have a conflict. Okay, so we know how to fix the conflict, right? So 3 spaces, 1, 2, 3. So what we're gonna do is, one by one, let's fix 2 over here. That means we have 1 digit for sure as our final digit. Okay, and now we can have 1, 2, sorry, not 2, 1, 3, or 4 as our first digit. Okay, acha, that means we have 3 options. So in total, we started off with how many digits? In total, we started off with 1, 2, 3, 4, and 5. Of the 5, how many of them are gone? 2 of them are gone. Okay, so that means how many are we left with? We're left with only 3. Okay, so 3 into 3 into 1 is equal to what? Is equal to 9. Acha. Now, is this the only possibility?
No.
Now?
Possibility where you're gonna have 4.
Yep, we can have 4 as the last digit. So that means we now have 1 digit for sure as the last digit, which means that you can now have 1, 2, or 3 as your first digit. Okay, so that means now you have 3 options. Yep, it's going to be the same. Okay, and since we started off with 5, 2 of them are gone. 1 is the last and 1 is the first digit. So that means now you're left with 3. So 3 into 3 into 1 is equal to 9, and altogether you now have 18. Okay, so now let's add them all up. So 2 plus 8 plus 18 equals to what? 10 plus 18 is equals to 28. So you can have 28 digits such that they're all less than 500 and even. Okay, so take a good look at what I've done. Let me know if you have any questions. We can minus 1 into 2p1 into 3p1. Mohammed Hassan, can you explain what you're saying? I think you're onto something. We can minus 1 into 2p1 into 3p1. So what you're saying is that we find out the possibility of the opposite and subtract it. Yeah. Yeah, you can try that. Sir, can you please re-explain how did we get 3 in between? Yeah, sure. Okay, so see how many digits did we start with? We started off with 5. Okay, 1, 2, 3, 4, and 5. If you have one number fixed as your last digit, that means you just have one option. Okay, so 5. So we started off with 5. Now one of them is gone. That means you're now left with 4. Okay, but there's another restriction which you need to fulfill, and that is that the number has to be less than 500. So if you want to make a number that's less than 500, a 3-digit number, that means you can only have 1, 3, or 4 as your first digit. Okay, so we always settle the restriction first. Restriction is that it should be even and it should be less than 500. So once the two restrictions are settled, how many numbers did we start with? We started off with 5 numbers. Of the 5, 2 of them are gone. Okay, 1 as your last digit and 1 is your first digit. So 5 थे, 2 चले गए, अब कितने रह गए? For the second digit, 3 रह गए. ठीक है? And the same is true for the other case. Okay. All right. Now, B part 1. Let's see what it says. So it says here, a committee of 8 people is to be chosen from 7 men and 5 women. Find the number of different committees that could be selected if the committee contains at least 3 men and at least 3 women. Okay, now, so first thing you want to do is, you want to find out all the possible combinations that can have at least 3 men and 3 women. Okay, keeping in mind that the total number of people that we're selecting is 8. Okay, so we're selecting 8 people. And the condition is that it should have 3 men, and 3 women. Sorry. Okay, now let's think of all the possibilities. So can we have 5 men and 3 women? Is that possible?
Yeah.
Absolutely. Okay. Can we have
4 and 4?
Yeah, we can have 4 men and
it's going to be 3 and 5.
4 women. Yeah, that's true. 4 men, 4 women. Okay, at least 3 hai, total 8 hai, nothing to worry about. And at the same time, we can also have 3 men and 5 women, right? Acha, what about yeah, I think that's it. There's no other possibility, because we can't have 2 men and 6 women. Well, you can't have that to begin with because you're only selecting from 5. Okay, and at the same time, you can't have 6 men and 2 women, because that way the condition isn't met. Okay, so any other possibility that you guys can think of? Okay, the answer to that is no anyway, because there is no other possibility. Okay, so how many ways can we select 5 men from 7? That's 7C5. And how many ways can you select 3 women from 5? So that's 5C3. Okay, let's see what this is equal to. In fact, I want you guys to work this out. Okay, I'm writing down the calculation of 4 men and 4 women. Okay, so how many ways can you select 4 men from 7? So that's 4C4. And how many ways can you select 4 women from 5? So that's 5C4. Okay, whatever that is equal to. And then how many ways can you select 3 men from 7? So that's 7C3. And how many ways can you select 5 women from 5? So that's 5C5. Okay, so can you guys give me the answer to this now? 7C5 into 5C3?
Sure, it's 200.
Thank you. Okay, what about this? 7C4 into 5C4?
175.
175. Thank you. What about this? 7C3 into 5C5?
35.
35. Yeah, that's what I thought. Okay, so let's sum this up. 210 plus 175 plus 35. 420. There you go. That's it. Okay, now the question is, why are we adding this? Okay, a lot of times students have this confusion that when do we add? So see, all of this, 5 men, 3 women, 4 men, 4 women, 3 men, 5 women, are basically different ways of fulfilling the same condition. So when you have different ways of fulfilling the same condition, you find out the number of ways it's done and then you add it. Okay, so I hope that confusion is now clear, that when you have multiple ways of fulfilling the same condition, then you find out all the ways it's done and then you add it all up. Okay, Acha. Now let's do part 2. Part 2 says the oldest man or the oldest woman, but not both. Okay? So these are your keywords. Must be included in the team. Okay? Now I'll do this question. If you guys know the answer to this, that's great, but let me solve it. So oldest man and oldest women. How many people are these? These are 2 people. Okay? Now, from these 2, how many do we have to select? We have to select 1. Okay? Acha. So that's 2C1. Okay? Now, how many people were we selecting from? We were initially selecting from 7 plus 5. Okay? Which is equal to what? Which is equal to 12. Okay? Now, if I have to select only 1, okay, from 2 people, so that's 2C1. Okay? That means now how many people do I have to select further to complete the team of 8 members? So I have to select 7 more. But the question is that how many people will I now select from? The remaining 7 people, how many will I select from? So initially you had 12. Now you're going to subtract the 2, which is the oldest man and the oldest woman. So that means now you're selecting from 10. Okay. Why are we subtracting both? Okay, if you think about it, select to koi ek hoga. Why are we subtracting both? Because it says but not both. So you have to make sure that the remaining 7 people you're selecting from does not include either the oldest man or the oldest woman, whoever is not selected. See, 2C1 means what? 2C1 means that it's either the oldest man or the oldest woman will be selected. But we have to make sure that the one is not selected does not end up being selected again when we're selecting the remaining 7 people. So that is why we subtract 2 from 12. So that means now we have 10 people to select from. And how many are we selecting? We're selecting 7. Okay, does everyone understand this? The answer is 240. There you go.
Okay, so is it possible if you can zoom out so I can see it?
Yeah. I can, absolutely. There you go.
Thank you.
You're welcome.
Oh, I'm done, sir.
All right, what about the others? Any questions? Anything that's not clear? Anything you want me to go over one more time?
So why won't it be 6?
Why would it be what? 6?
Why won't it be 6? Like 10
Okay.
C6.
That's because we've only selected 1. No? And how many people do we have to select? We have to select 8. Okay, so if you've selected 1 and you have to select 8, so that means you have to select 7 more.
Okay, sir.
Sir, can you please go over second digit in A part? Yeah, sure. So, wait, second digit or 2 digit? What do you mean? 2 digit, okay. So basically, dekho, if you're making a 2 digit number, so it's inevitable that it's going to be less than 500. Okay, so that means that's one less condition to fulfill. The only condition that you have to fulfill is the fact that it's even. Okay, so how do you make a 2 digit number even? You make sure that the last digit is even. Okay, and given that the options that we have to choose from, you can only have 2 or 4 as your last digit. So 2 and 4, how many options is that? That's 2 options. Now, how many digits did we start with? We started with 5. Okay, and now of the 5, one of them will be gone as your last digit. So how many options do you have for the first digit? You have 4 options. So 4 times 2 equals to 8. And we listed all the 8 digits. Okay, which obviously you don't have to do. Okay, I've done it. But, you know, this is how it is. All right, good to hear that. Okay, now, let me pick out another question for you guys. Just a minute. I'm trying to look for that must be included or must not be included type of a question. So here's a question. You're welcome. This is from October-November 2014, paper 2, variant 3. So you guys want to give part 1 and part 2 a shot? I'm sure you guys can do it, Vasa. Sir, is there a possibility that a part has both combination and... Okay, so in one question it's possible, like part A could be a permutation question and part B could be a combination question, but within the same part, it's not possible. Okay. All right, do we have the answer to part 1? It's pretty easy. You're selecting 4 people. Okay. 495 from a total of 12. Okay, you don't have to worry about who ends up being in the team. Okay, so 12C4, which is, as you guys say, 495. That's the correct answer. Good job. Okay, now do part 2.
Sir, is the answer to part 200?
So I heard 200. Yeah, that part is correct. What after 200?
It's 210.
Yep, 210 it is. Okay. So why 210? Because you have to select 2 male and 2 female members. So that means 7C2. From 7, you can have 2, and the remaining 2 have to come from female members. So that means 5C2. So 7C2 into 5C2. So 21 into 10, that's equal to 210. Okay, I hope everyone understands what I've done here. All right, now part 3. Okay, so I'll do part 3 because this is a different category. Once I'm done with all the categories, then I'll give you guys questions to solve, okay? So part 3 says, find how many different committees of 4 could be selected. Sir, please explain part 2 again. Yeah, sure. So dekho, you're selecting a committee of 4. Okay, always highlight what's important, okay? And what's important is how many you're selecting and how many you're selecting from, okay? And also the restriction. So the restriction is that you have to select 2 male members and 2 female members. So that means from the 7, you have to select 2. So how do you do that? 7C2. Okay. And then from the 5 women, you have to select 2 because the total has to be 4. Okay. So how do you do that? You do that through 5C2. So 7C2 into 5C2. And there you go. That's it. That's your answer. Okay, great. Acha, now let's have a look at part 3. So let's first read the question, see what it says, and then we're going to solve it. So it says a brother and sister, Ken and Betty. Okay, so they're the same people, right? Ken and Betty are the brother sister. Are among the 7 men and 5 women. Okay. Find how many different committees of 4 could be selected so that there are 2 male and 2 female members, which must include either Ken or Betty, but not both. Okay. Now, so let's read it again. There are 2 people, Ken and Betty, they're brothers and sisters, okay? And you still have to select in such a way so that you have 2 male and 2 female members, but at the same time, you have to make sure that it's either Ken or Betty that are in the team, but not both, okay? For whatever reason. So I'll repeat. You're still selecting 4 members, and you still have to make sure that you have equal number of male and female, but another condition that you now have is that you have to make sure that it's either Ken who's selected or Betty. Okay? You can't select both of them. So what does that mean? That means if Ken is included in the team, what happens to Betty? As a result, she will be excluded. Okay? So Betty gets excluded. Or what's the other possibility? The other way around, right? Or it could be that if Betty is included, as a result, what happens to Ken is that Ken gets excluded. Okay, that's the only way that you can make sure that you only have one. Achha, let's not jump to conclusions. Okay, so let's go through the solution. It's a 4-mark question. So let's see how we can select Ken and not Betty. So Ken is 1 member. That means 1C1. Okay. Now, Ken is the brother, right? Yeah. So we have 7 men to choose from. Okay. Ken is a man who has been selected. That means now you have 1 male member to choose. Okay. But how many to choose from, considering that Ken has already been included in the team? Okay, so that's a question for you guys. We had 7 men. Yes.
You're gonna have 6 men left.
Exactly. So we had 7 men to choose from. Ken, who is a man, has been included. So that means now you have 6 to choose from. And also how many to choose? Just 1 to choose. Because you have to make sure that they're equal. So how do you do that? 6C1. Okay. Now, this is how Ken is included. Okay. And this is how the 1 remaining male member is also selected. Now you have how many women to choose? No, two. Two women to choose. Why? Because you have to select equal number of male and female. Okay, two male and two female members. I should have highlighted this. Two male and two female members. So far, what have we done? We've selected two male. Okay, we've selected two male members. Okay, I'll repeat in any case. So here's Ken being selected. Okay, it's always good to write 1C1. Okay, now it's not going to make any difference. Let me tell you that. Okay, but it's always good to write it so you can see what you're doing. So this 1C1 means that there's Ken. Okay, who is selected. So how many ways can you select Ken from Ken? It's just one. Okay, but it's always good to write that. And now you had 7 men to choose from. If Ken is excluded from that because he is selected, so that means now you're selecting 6 and you have to select 1. Why? So that you can make sure that you have 2 male and 2 female members. Okay, so this way we've selected 2 male. Now we have to make sure that Betty does not get included in the team. So how many women do you have to choose from without any restriction? You have 5. Now you have 4. Because now you have to make sure that you don't end up selecting Betty. And the only way that you can make sure that you don't end up selecting Betty is to exclude Betty from the 5 women that you were selecting from and then select from the remaining 4. And the question is, how many are we going to select? How many women are we going to select? 2. 2. 2, 2, 2. Not 1, 2. Why? Read the question. 2 male and 2 female. So this is us selecting 2 female members. So what's the total? Let's work this out. This is not the final answer, by the way. Okay. 36, 1C1 into 6 into 6. Yeah, that's correct. 36. Okay. Now, let's fulfill the other condition, which is that Betty is included. So how do you include Betty? By doing 1C1. Okay, there's one Betty, you have to select her, 1C1. Okay, again, you can totally not do this, but I will suggest that you do it so you can clearly see what's going on. Okay, now let's complete the remaining female members. So Betty is a female, she has been included. 4C1. So that means now we had 5 women to choose from. Since Betty is already in the team now, that means now we're selecting 1 and we're selecting from 4. Okay, so from the 5, 1 is already included. So how do you do that? 4C1. And then Ken, we have to make sure that Ken ends up not being selected. So we have 7 members to choose from. This 7 includes Ken. So how do we exclude Ken? We take 6. Okay, that means now we're selecting from 6. And how many are we selecting? We're selecting 2. Okay, so let's figure this out. So 1 into 4 into 6C2. So 1C1 is going to be 1, 4C1 is going to be 4. You guys don't have to figure it out formally. So this is equal to what? This is equal to 60. And now let's find out the total. So what's the total equal to? The total equals to 36 plus 60, which is equal to 96. Okay. Now take a good look at what I've done. All right. Even if you have to spend 2 minutes reading the question, understanding the working, doesn't matter. And let me know if you have any questions. Okay, but पहले ज़रा सही से समझ लें इस question को, ठीक है? If whatever question it is that you have, see if you can find the answer to it yourself. Okay, that way you learn more. But if you can't, it's okay. Feel free to ask. So here's that question. Okay. This is fairly recent. It's from October-November 2018, paper 2, variant 3. Now, I want you guys to read the question. The first part you guys can solve without my help. Tell me the answer. So, anyone? 20C11, that's correct. Okay. Why? Because you have a score of 20. Score basically means the total that you're selecting from, which includes 2 sets of twins. Achha, how many people is that? 2 sets of twins?
4 people.
4 people, yeah. Is available for a selection for a cricket team of 11 players. Calculate the number of different teams that can be selected if there are no restrictions. Okay, so 20C11, yeah. So a cricket squad is of 11. Oh, sorry, not the squad. Cricket team is of 11. So that's 169. No, 167,960. Yeah. Okay. Okay, now here's something interesting. It says both sets of twins are selected. Okay, now let me do this one. So one set of twins means how many people? 2. Okay, and if you have to select them, that's 2C2. Okay. And then the next set of twins, how many people? 2. And if you have to select both of them, so that's 2C2. Now I know that you guys can also do 4C4. Okay, makes no difference. But this is how I like to do it. Okay, I like my working to sort of tell the whole story. Okay, so this working is telling you the whole story, that you have 2 sets of twins. Okay, which you have to select, and then you have one set of twins which you have to select, and then you have another set of twins which you also have to select. Okay, and again, like I said, you could have done 4C4. See, 2C2 is going to be 1, 2C2 is also going to be 1, 1 into 1 is going to be 1, 4C4 will also be 1. Okay, so it makes no difference. Okay, Acha. Then you were selecting from a score of 20. Now, if both sets of twins actually are selected, that means how many people is that have been selected? 4. Okay. So previously you were selecting from 20. Now you're selecting from how many? Now you're selecting from 16. Okay. Previously you were selecting 11. Of the 11, 4 have been selected. So that means how many do you have to select to complete the team? 7. Very good. And where's the 7 coming from? 11 minus 4. Okay. So that means 7. So that's 16C7. Okay. So let's work this out. Now you could have only done 16C7. Okay. But see, there's no story behind that. Okay. I mean, as long as it's clear to you, it's fine. Like, it's not like you're gonna get any extra marks for this. But if you want to increase your understanding of the concept, this is how I would suggest that you solve the questions. So 11,440 is your final answer. Now, before I do the next part, let me know if you have any questions. Okay, great. Acha. Part 3 says one set of twins is selected. Acha, I'm not checking the chat, so please, whatever question. Acha, okay, no question so far. Great. So part 3 says one set of twins is selected, but neither twin from the other set is selected. Okay. Now, one set of twins is selected. Okay, so one set of twins. How many people is that? It's not. It's 2. Okay, great. One set of twins, that means you're selecting the complete pair. Okay, so how many sets of twins do you have? Let's say A and B. Okay, हमने अपनी तरफ से नाम दे दिया, A B कह दें, P Q कह लें, X Y कह लें, it makes no difference. Okay, now if you're selecting 1, what does that mean? That means 2C2. Okay, now let's say this is representing that A is selected. Okay, now so that's 2C2. So how many people have we selected? We've selected 2. So that means in order to complete the team, we now have to select 9 more. But you have to make sure that if A is selected, the remaining 9 members don't end up coming from the other set of twins, which means set B. So how do you make sure of that? You had 20 people to choose from. Okay, so now the remaining 9 people that you're going to choose will not be from 18. Okay, so you'll not subtract 2 from 20. Instead, what you'll subtract is 4 from 20. So what is that? That's 16. And previously you were selecting 11 people. Now that 2 have been selected, that means now you're selecting how many? Now you're selecting 9. So that's 2C2 into 16C9. किसी का mic खुला हुआ है, please उसको बंद करना. I can hear myself for some reason. Okay. But the thing is, if you just leave it over here, you get 11,440, which apparently is not the correct answer. Why is that?
Because the other set is selected.
Exactly, because there is a possibility. The question didn't specify which set of twins do we have to select it. Do we have to select? It only said one set of twins. Okay, which is why we labeled them. Okay, which is why we called one A and the other B. So what's the other possibility? The other possibility is that what if B is selected? Okay, so how different is the working going to be from the previous one?
It's going to be the same thing.
It's going to be the same thing. So how about we just take one value and then times it by 2. Okay, so
22,880.
22,880. There you go. Now, as always, take a good look at what I've done. Let me know if you have any questions. Okay, great. All right, part 4. Exactly. Achha, by the way, I said at the beginning that this is that type of question where it can't be separated. This is still not that kind of a question. Okay, but the next question I guarantee will do that kind of question. Okay. So why did we subtract 2 from 11? Okay, so why did I subtract 2 from 11? Because remember, we're selecting a team of how many people? We're selecting a team of 11 players, okay? And if 2 of them have already been selected, that means now in order to complete the team, you have to select how many? Chalo, you answer that question. Now in order to complete the team, how many members do you have to select? 9, there you go. So that's the answer to your own question. Okay. Acha. I think we will minus 4. Minus 4 from what? From 11? Are we going to minus 4 from 11? Is that what you're saying? Acha, wait. Acha. If you're talking about part 4, okay. I think you're talking about part 4. Acha. Okay. Okay, let's do part 4. Let's see what it says. So it says exactly one set of twin from each set of twins is selected. Okay. So let's say we have set A, okay, from which we need to select how many? From which we need to select, let's read the question again. So you have 2 sets of twins, okay, and the total is of 20. So let's say that from set A, you're selecting only 1. So how do you do that? You do that through 2C1. Okay, now the same is true for the other set. Okay, the same is true for the other set, 2C1. And now you have to make sure that the remaining 9 players that you're selecting from the remaining 16. Why? Because from 20, you need to subtract 4, which is the 2 sets of twins. And from 11, we're going to subtract 2. We're not going to subtract 4, okay? Because we still have to select the remaining 9 members. So how do you do that? You do that through 16C9. Okay. Now if you work this out, let's see what do we get. 2C1 is simply 2, so you can just do 2 times 2 into 16C9, which is 45,760. And there you go. That's the correct answer. Yep, 45,760. Okay, now as always, take a good look at what I've done. Let me know if you have any questions. Won't we double the answer of part 4? Why would we do that? Why would we double it? Because it would be either of the twins in a... Kya? Can you repeat that? Why would we double it? देखो हमने दोनों सेट में से एक ही को सिलेक्ट करना है ना. So how do you select one twin from one set? 2C1. Okay. And then from set B also you need to select only one. So how do you do that? 2C1. Okay. इसमें कोई और पॉसिबिलिटी तो नहीं हो सकती. और पॉसिबिलिटी क्या होगी? सोचो और मुझे बताओ if it's clear to you. सर जो हमने twin nahi select kiya from a set of twin, that could... Okay, so when we say 2C1, okay, I get what you're saying now. So when we say 2C1, what's the answer to that? 2C1 का आंसर क्या आएगा मुझे बताओ. Minhal, 2C1 is 2. So what is the 2 representing? The 2 is representing, so let's say A एक set है, ठीक है, उसमें जो twins हैं वो हैं X and Y. So when you do 2C1, the answer is 2. That means you've already included the possibility of X being selected or Y being selected. So you don't have to double it anymore. Dekho, if you're confused as to why we doubled it over here and why not over here, so here there was a different story. Here we could have selected A, set A of twins, okay, or we could have selected set B of twins. Okay, so that's why we multiplied it by 2. But here, when we do 2C1, the answer is what? The answer is 2, which means that we've already taken into consideration the fact that we could have selected one twin from set A or the other. That's how we get 2. अगर हम ये करते हैं ना, ओके, अगर हम ये करते हैं ना 1C1 इंटू 1C1 एंड देन इंटू 16C9, तो फिर हम अपने फाइनल आंसर को टाइम्स 2 करते हैं, बिकॉज हमने एक को सिलेक्ट किया, ठीक है, हमने उन दो सेट में से एक एक को सिलेक्ट किया, ओके, एंड नाउ वी आर मल्टीप्लाइंग इट बाय 2 बिकॉज द अदर कुड हैव आल्सो बीन सिलेक्टेड, ओके. ऑलराइट, नाउ वैसे हम 1 से भी 2 से भी नहीं मल्टीप्लाई करते, फिर हमें 4 से मल्टीप्लाई करना पड़ता है बिकॉज देयर वुड हैव बीन डिफरेंट डिफरेंट कॉम्बिनेशंस. या सो जस्ट अ मिनट. या वी वुड हैव हैड टू मल्टीप्लाई इट बाय 4 बिकॉज एक के साथ एक, फिर दूसरे के साथ एक, कॉम्प्लिकेटेड हो जाता, ठीक है. Unless you know, unless it's absolutely clear to you what you're doing, then it's fine, but if it's not, then you stick to this. Okay, so here's a question. As far as the first 3 parts are concerned, I'll let you guys solve them. Okay, take your time. The first 2 are pretty easy. Part 3 is also pretty easy given that you spread it out and you don't rush into it. Okay, and then as far as part B is concerned, oops, sorry, as far as part B is concerned, that we will solve together. And keep sharing your answers as you solve them, okay?
So will you have a break today?
Do you guys need a break? Tell me we will have a break. Okay, we'll have a namaz break.
So there's part 1, 126.
No, I think you've used combination.
So is it 15,120?
Yep, 15,120 it is.
So and is part 2, 1,680?
Good job, spot on. So I'll write down the answers one by one. So the answer to A part 1 is 15,120. The answer to part 2 is 1,680. Okay, now let's have the answer to part 3. Okay, take it easy in part 3. I'm not solving it. I'm just doing it in my head. Is it a conflict situation?
Yes, it is.
Yes, it is. It's a conflict situation. So you do it step by step. Okay, and looking at the marks, you can sort of tell. I don't want you guys to make this a blanket rule, okay? But, you know, chances are it is a conflict situation looking at the marks. 3570. No, I'm afraid not. That's not the correct answer. Yes, Ahnaf, your answer is correct. Mohammed Hassan, your answer is also correct. Okay, good job, guys. Do you guys want me to tell you the answer? Let me know when you want me to give you the answer. No, I'm afraid, Kanya, that's not the correct answer. Yes, Momin, good job. That is the correct answer. Okay, who else? Hamiduddin, I'm afraid that's not the correct answer. No, Minhal, I'm afraid that's not the correct answer. So I'd like you guys to share your working with me, you know, so that I understand the kind of errors you guys are making. Okay, so I'll do it now. So the correct answer is 2310. Okay. Now, so let's see what the condition is. So it says the code is even and greater than 70,000. Okay. So if you want to make the code even, you can have 2, 4, 6, or 8 as your last digit. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Okay. And if you want to make it greater than 70,000, so that means you can have 7, 8, or 9 as your first digit. Okay, so clearly it's a conflict situation. Why? Because 8, you can see, is being repeated. So you know what you can do? You don't have to fix 2, 4, 6, and 8 one by one. What you can do is, where exactly is the conflict, or who's causing the conflict rather? It's 8 that's causing the conflict, right? So you sort of deal with that first. Okay, so how do you deal with that first? So first you fix 8 as your first digit. Okay, so that means you only have one option as your first digit. Okay, so that means now you can have 7 or 9 as your first digit. Okay, I'll repeat, you fix 8 as your last digit, that which means that you can now have 7 or 9 as your first digit. Okay, so which means that you have two options. Now we started off with a total of 1 2 3 4 5 6 7 8 9. Okay, so we start off with 9 digits. Okay, so for the places in between we have 3 spaces, and we have how many digits available? We started off with 9, 2 of them are gone, so that means now we have 7 available. Okay, so we have 7 available and we have room for 3. So 2 into 7 be 3 into 1. So what's the, oops, sorry, into 1. So what's that equal to? That's equal to 420. Okay, acha. Now what do we do? So we've resolved the conflict, right? It was 8 that was causing the conflict. We've resolved that, which now means that we can comfortably have 2, 4, or 6 as our last digit. Okay, which means that what is the possibility, or what can we have as our first digit? We can have 7, 8, or 9. ठीक है, समझ आ रहा है सबको? 2, 4, 6, you can see that there is no conflict. 2, 4, 6 are separate numbers, 7, 8, 9 are separate numbers. Okay, that means you have 3 options over here and you have 3 options over here. And now in between, we started off with 9 digits, of which 2 are gone. That means now we have 7 to choose from, and we have room for 3. So let's figure this out. 3 into 7 p3 into 3, which is equal to 1890. And now you sum it up. 1890 plus 420 is equal to 2310. That's your final answer. Yeah, sure. So देखो, second part आपको जब समझ आएगा when you fully understand the conflict. Who is causing the conflict? It's 8. Okay, 8 is the problem. So what we did was we fixed. Oh, acha. Okay, I thought you meant this is the second part. Yeah, sure, I can explain that. So how many ways can this code be divisible by 5? What should you have as your last digit? What are the kind of numbers that are divisible by 5? You have the numbers that end in either 5 or 0. So here we don't have 0 as an option, we only have 5. So that means you need to have 5 as your last digit, which means just 1. Okay, acha. Phir, since there is no other restriction, so we can start from the first digit. So we had a total of 9 options to choose from, of which one of them is gone. Okay, so that means now we have 8 options to choose from, and we have room for how many? We have room for 4. So that's 8p4. Okay, or you can do 8 into 7 into 6 into 5. So 8p4 into 1 is 1680. You're welcome. Acha, for solving this, can we not keep 8 in the first place instead of the last place? Yeah, you could do that. You could keep. But the thing is, if you. Okay. So we still have to make sure that the number is even. Right? So if you keep 8 in your first place, then you will have 2, 4, and 6 as your last digit. But that didn't really help in solving the question. Now, that didn't really help in minimize the working. So if you keep 8 as your first digit, so if you keep 8 as your first digit, that means you'll have to do the same for 7, then you'll have to do the same for 9. Okay, so you can spread it out like that also, you will get the same answer. Okay, Minhal, you can first fix 7 as your first digit, and then 8, and then 9, and then you'll get the same answer. Do you want me to do it like that? Minhal, do you want me to do it like that? I've sent you my working. Okay, so I'll just check your working. So पहले आपने 7 fix किया. Okay, so that means you can have 2, 4, and 6. 2, 4, 6, 8. So 9. So yeah, nothing wrong with that. 7. So are you not getting the correct answer? Okay, you've probably made a calculation error because this working is, there's nothing wrong with that. 2, 4, 6, 8, 9. Okay, let me just solve part B, then I'll take a look at your working. Okay, theoretically I don't see anything wrong with it. Probably we've made a calculation error or something. How will we know that we can use either P or C in questions like these? Okay, so chalo, that's a good question. So let's say the password of your phone is 1234. Okay, although I hope not. Okay, because that's very easy to crack. So if someone enters it as 4321, will the phone unlock?
No, it won't.
It won't. Why? It's the same digits. You can argue that's the same set of digits.
But then the passcode needs to be in the same format, in the same placement as well.
Omar is saying, sir, how do you know? Okay. See, like I said, I hope it's not, because it's very easy to crack. Because it has to be in the same order. Okay, so that means every time there's a question that's dealing in numbers, the order is important. Okay, and when the order is important, what does that mean? That means it's permutation.
Yeah.
Okay, जब हम team बना रहे होते हैं, so let's say there are two people, okay, A, B, okay, so if you're making a team, doesn't matter in which order you select them, okay, it's still the same people. Okay, someone proposes the idea of having A and B in one team, and someone else proposes the idea of having B and A in one team, so technically they're both saying the same thing because it's the same people, right? So if you have a question where you're selecting, where you're making a team, where you're choosing, okay, the order doesn't matter, which means that you will use combination. If you have a question where you're making a number, a passcode, arranging books, or something like that, arranging people, okay, for a photograph, you'll have questions like these also. Then the order is important, okay? Even if you're arranging people, okay? So when the question categorically says arranging, it's important. The order is important. Even if you're arranging them for a photograph, yes, it's the same set of people, but since we are arranging them, that means we have to consider all possible arrangements, which means the question falls in the category of permutation. Okay, but when you're making a team, in a team such that there is no ranking, there is no order involved, then the order doesn't matter. Okay, but if there's ranking involved, like for example president, vice president, secretary, or captain, vice captain, all-rounder, okay, then even though you're making a team, but the order inevitably becomes important, because who plays as captain and who plays as vice captain matters. Okay, A playing as captain, B playing as vice captain, and the other way around, where A plays as vice captain and B plays as captain, is a completely different team. Okay,
And sir, how the batting lineup goes in
yeah,
cricket.
so that means, so that, okay, that happens later when you've selected a team. Okay, when you've selected a team, and then within the team you're creating hierarchy. So what does that mean? That means it's permutation. Okay, because now you've selected the people that you want to arrange, and now you're arranging them, okay, for a batting lineup or for whatever it is. Okay, so that means it's permutation. Okay, so you really have to understand like the whole theme of the question. Okay, and it's not like you have to like really put some thought into it to understand what's going on. You practice a few questions, and then you will just read the question and understand what this question is asking you to do, whether it's a permutation question or a combination question. Okay, so there won't be much thought to put into it. It'll just come to you naturally. Okay, now here's part B. Part B says a team of 6 people is to be chosen from 8 men and 6 women. Find the number of different teams that may be chosen. Okay, so what do you think this is? What do you think this is dealing with? You're welcome, Ibrahim. Yeah, it's combination. Okay, because you're selecting a team, okay, and there is no restriction, so it's definitely combination. All right, now part 1 says there are no restrictions. Okay, so I want you guys to do part 1 and part 2 yourself without my help. 14C 6, that's correct. So you have 14 members to choose from and 6 to choose, so that's 14C6. And what's the answer to that? 14C6 3003. There you go. Okay, there are no women in the team. Okay, how do you do that? So that means the 6 people that you're choosing will have to come from the 8C6 will have to come from the men. Okay, so that's 8C6. That's 28. Okay, now this is the part that I was looking forward to. There are a husband and wife who must not be separated. Okay, so how many ways do you guys think it's possible for a husband and wife to not be separated? Yeah, exactly. So they're either in the team or they're not in the team. So that means they're together. Okay. So
But sir, couldn't it also be the order that would matter? If it's talking, they must not be separated.
how's that? How does that work?
Let, let's say that the team is of 6 people. If we make 6 dashes, wouldn't the husband and wife have to be together? So wouldn't they be
Okay, okay,
only?
okay, okay. You're not arranging them. That's the thing. You're not arranging them. It's not like they're lining up for a photograph or something. You're just selecting them. Okay, so they have to be in the team no matter in what order they're selected.
Okay.
Do you get what I'm saying? Because
Yeah.
you're only selecting, you're not arranging them. Okay. Acha. So there are a husband and wife who must not be separated. Okay, it's a 3-mark question. So let's do it accordingly. So one possibility is that both are in the team. Okay, so husband and wife, how many people is that? That's 2 people. Okay. Now, what if I told you that there are 2 people who must be in the team? How do you do that? You do that through 2C2. Okay. Now, again, you can totally not do this because 2C2 is going to be 1, but this is how I would prefer it. Okay. And if there are 2 people who are in the team already, so that means previously you were making a team of 6, now you're making a team of 4. Previously, you were selecting from 14. Okay. And now from the 14, 2 are gone, 1 man and 1 woman. That means now you're selecting from 12. So the remaining 4 people that you're selecting is coming from the remaining 12 people. Sorry, not 12C2, 12C4. Okay, so let's see what this is. 2C2, again, it's going to be 1 into 12C4, which is equal to what? Which is equal to 495. Okay, which is not the final answer because there's another possibility. What is the other possibility, like you guys mentioned, Abhi, thodi der pehle? Yeah, both are not in the team. Okay, so if both have to, I mean, if you have to make sure that both of them are not in the team, that means you're not selecting from the 14 people. You are now selecting from 12 people. Why? Because you've excluded them from the beginning so that they don't end up being in the team. Okay, so you had 14 people. Of the 14, you had 8 men and 6 women. So from the men, you separated that husband. Okay, and from the women, you separated that wife so that you don't end up selecting them. Okay, so what does that mean? That means now you're selecting from 2. And how many are you selecting? You're still selecting 8. Sorry, 6. You're still selecting 6. So that's 12C6. Okay. We're not separating them because they have been selected. We're separating them because we have to make sure that they're not selected. Okay. And we're still selecting 6 people. So what is that equal to? That's equal to 924. Now you sum it up. 495 plus 924. Let's see what that is equal to. No, wait. 425 plus 924. That's equal to 1, 3. No, wait a minute. 425 plus 924 is equal to 1349. Terrible. Let me just check the answer. I think I might have made an error. Either the answer is incorrect or I've made an error. Just a second. 12C6 is 924. Oh, no, wait. It's 1419. Yeah, it's 1419. Made a calculation error. I don't know what I did. Let me check. 12C6 plus 495. Yeah, so it's 1419. Okay, so I'll explain this again. So one possibility is that both of them are in the team. Okay, so that means there are 2 people who must be selected. So that's 2C2. Okay, and now you're not selecting from 14. 8 plus 6, that is. You're now selecting from 12 because you've included that man and you've included that woman. Okay, and since 2 people are already selected, that means now you're selecting only 4. So 2C2 into 12C4, that's 495. The other possibility is that both are not in the team. So how do you make sure that there are 2 people who are not in the team? You do that by simply doing 12C6. Why? Because there are a total of 14 people to choose from, and you have to make sure of the 14 you don't end up selecting 2. Okay, 1 husband and 1 wife. So you exclude them and now you select all 6 of them from the remaining 12. Okay, so there you go. 924 plus 495, which is 1419. Sir, why did you add the values? Okay, anyone who'd like to answer that question? Why are we adding this?
Because there are 2 possibilities.
Yeah, because there are there are 2 ways of fulfilling the same condition. Okay, one is that both are in the team. Okay, which means they're not separated, and the other is that both are not in the team. Okay, which again means that they're not separated. All right. Now, Any other questions that you'd like me to answer? Sir, I've sent you a question on WhatsApp. Can you please explain that? Okay, sure. When you have topics like permutation, combination, probability, I'm talking about math probability, okay? What else? Even numbers to some extent, rational numbers and all that. In that case, the solutions are misleading, okay? No, the answer must be the same, but I'm talking about the solution, okay? The solutions are misleading. And marking scheme B, yes, I agree. It's possible that it may be the same, but if you compare my solutions compared to what they've done it in the marking scheme solutions for this topic at least are pretty straightforward, because they're not, practically speaking, they're not for us, they're for the examiners, okay? So jo sare wo marks diye hue hote hain, M1, A1, all that, that's for the checker basically, okay? That if you see this, you give this mark. If you see this, you give this mark. It's not really a detailed solution, okay? So you just have to watch out for that. That's why, like, for example, a lot of things that I've done over here, how I said that if you're like for example, that Ken and Betty wala question, okay? So if you're selecting Ken, so you do 1C1. So chances are you won't see that in the marking scheme, okay? And that doesn't mean that the solution is wrong. It's just that it's not necessary, okay? But I like to do it so that my solution is sort of telling a story, okay? Now, so here's another question which Mohammed Hassan has asked. This is from Major 2015, paper 1, variant 2, okay? So part A is pretty simple. A part 1, it says the security code is to be chosen using 6 of the following, okay? Now, even though the word is used is chosen, but what do you think about a security code? You think the order is important?
Yes,
Of course it's
permutations.
important, okay? So if the order is important, that means that you have to use permutation, okay? Now let's see. So you have the letters A, B, and C, so that means you have 3 letters to choose from. The numbers 2, 3, and 5, so that means again you have 3 numbers to choose from. And the symbol, star, kilo, asterisk, kilo, and dollar. Okay, so that means you have 2 symbols to choose from. Okay, so altogether you have 3 plus 3, that's 6. 6 plus 2, that's 8. So you have 8 to choose from. Let's read what the question says anyway. None of the above may be used more than once. Okay, find the number of different security codes that may be chosen if there are no restrictions. So that means 8P6. Okay, and why 6? Because you have to use 6 of the following from a total of 8. So what's that equal to? Let's see, 8P6, 20,160. There you go. That's your answer. Okay. Part 2. Part 2 says the security code starts with a letter and finishes with a symbol. So remember, it's a 6-digit security code that we're forming. So 1, 2, let's first make 6 blanks, 3, 4, 5, and 6. Okay. So if it starts with a letter, so that means how many options do we have? We have A, B, or C. So that means we have 3 options. Okay. And it finishes with a symbol. So how many options do we have for the last digit? So we have the option of having a star and a dollar. So that means you have 2 options. In between, anything goes. Okay. So what that means is that you have 4 spaces available, and you have 6. What can you say? Altogether options to choose from. Okay. So 6 to choose from, room for 4. So how is that? That's 6p4. Okay. So 6p4 into 3 into 2. So let's do that. 3 into just a minute. Yeah, 2160. 2160.
Then won't it be 4p4?
Why 4p4?
So because 2 numbers have already been chosen, 3 and 2. So 6 minus 2.
No, it's not 6 minus 2, it's 8 minus 2. Because how many do we have in total? 3 plus 3, 6. 6 plus 2. Okay, so total that we have to choose from is 8, not 6. Okay? Okay, then it says the 2 symbols are next to each other in the security code. Okay, so how does that work? 1, 2, 3, 4, 5. Okay, now, no wait, it's 6, right? Yeah, 6. So the 2 symbols have to be next to each other. Okay, so let's say here are the 2 symbols. Okay, we group them, and the symbols can shuffle amongst themselves 2 factorial number of ways. Okay, now how many did we start with? We started off with 8 options. Okay, of the 8, 2 are gone. So that means how many do we now have? We have 6. Okay, that means here you can have 6. You have 6 options here. You have 5 options over here. You have 4 options over here, and you have 3 options over here. But you can't leave it at that. Why can you not leave it at that? So for example, up until now, 2 factorial into 6 into 5 into 4 into 3 is correct, but you can't leave it at that. Why is that?
So because the 2 factorial can be anywhere.
Yes, because the 2 factorial can be anywhere. Now, if it can be anywhere, how many options do you think we have? We have a total of, so think about it. You can have 2 factorial first, okay, and then 6, 5, 4, 3, 2, 1, okay, so this is one possibility. Just like that, you can have 6 first, and then 2 factorial, and then 5 into 4 into 3, so that's the second possibility. Or you can have 6 first, and then 5, and then 4, okay, and then you can have 2 factorial and then the 3, or you can have 6, 5, 4, 3, and then 2 factorial. So altogether, how many options do you think we will have? 5 or 5 factorial? Okay, so here you have to watch out. Will we have 5 or 5 factorial options? Think about it.
5 factorial.
Are you sure? 5 factorial.
No, so wouldn't it be 6 factorial?
No, it's not going to be 6 factorial either.
Would it be 5?
It will be 5. Okay. Now I'll tell you why 5. Okay. Now I know you guys may be connecting this with the question that we did earlier. Okay, where we made different units. The thing is that here we're not going to do 5 factorial. Okay. Here we will do 5 only. Why is that? Because this 6, 5, 4 into 3 has already taken into account the arrangement of these numbers. Okay, this 6, 5 into 4 into 3 has already taken into account the arrangement of these 4, not numbers, but these 4 options, basically, digits, symbols, or numbers, whatever it is. Okay, the only thing that we haven't taken into account is arranging all of these with this 2 factorial. And if you think about it, if you sort of spread it out, you will notice that yes, there are a total of 5 options only. How is that? Let me show you. So one is the one that we see above. Okay, the other is this option that you have 6 factorial first, and then you have this. Okay, and then there is another possibility. What is that? That is that you first have the 6 and 5, and then the 2 factorial. Okay, so that's the third arrangement. And then there is a fourth arrangement, which means that you have 6, 5, and then 4, and then these two. Okay, and then the final one, what do you think the final one is going to be? That you have 6, 5, 4, 3, and then in the end, you have the 2 factorial. Okay, so the reason why we're not multiplying it by 5 factorial, okay, which we were doing when we were arranging books and all that, that's because they were treated as different blocks, okay, and we were shuffling all the blocks. Here, when we do 6 into 5 into 4 into 3, that means we have already taken into account the arrangement of these 4 digits, numbers, symbols, whatever they may be. The only thing that we need to take into account now is how to shuffle this 2 factorial along with the remaining 4 spaces. Okay, and how many options do we have for that? You can clearly see that we have 5 options. So here's 1, here's 2, here's 3, here's 4, and here's 5. So that's why the answer is 2 factorial into 6 into 5 into 4 into 3 into 5. Let's see what that is. 2 into 6 into 5 into 4 into 3 into 5, which is equal to 3,600. There you go. Now, as always, take a good look at what I've done. Let me know if you have any questions. Sir, let's, for the third row, the possible arrangements you showed, can't 6, 5, 4 change among themselves? So that's the thing. The reason why we have taken 6, 5, and 4 suggests that they can change among themselves. Okay, why have we taken this 2 factorial here? The reason why we've taken this 2 factorial over here to show that the symbols can change amongst themselves. And when we take this 6, 5, 4, 3, this shows that here all of them can shuffle amongst themselves. Okay, but what we haven't considered is the possibility of keeping the 2 symbols together in between everything else. And how many options do we have for that? We have 5 options for that. So that's why we multiply it by 5. Okay. Anything else?
No. So sorry, are we starting lectures now?
No, not right now. We'll do it in the next class, inshallah. Not right now.
And sir, will the crash course batch have the maths class today?
Let me find out. Okay. I'll update you guys around 2:30. Okay.
Okay.
Inshallah.
Okay. Okay, so
Okay, Allah Hafiz. Anything, if you guys have any questions, feel free to ask. If you don't, then I guess that's it. I will share this worksheet with you guys, okay? I'll upload them in the I'll upload this in the OneDrive folder. Please solve as many questions as you can, okay? Since we've done all the concepts, I don't really have a restriction that solve these type of questions now and not these, okay? So you can solve all of them. There are you'll find answers at the bottom, okay? So if there's anything you guys don't understand, you can let me know. We'll discuss it in the next class, inshallah. Okay. So I'll stop here. I'll see you guys on Monday. Take care, everyone. Allah Hafiz. Allah Hafiz. Allah Hafiz.
Also, recording stop.
Oops.